All right. So when you need to calculate the pH of a weak acid or base, the first step is to set up a Rice table. What is our equation going to be here? Yes, HC7, H5O2 plus water. So we're going to do this just like a Bronsted-Lowry reaction. It's going to be an equilibrium because we're using Rice table. Now I'm going to go ahead and note that this is a liquid here. Now, so from there, this is an acid, so it's going to donate a proton. So this is going to become H3O plus, and then our conjugate base is going to be C7H5O2 negative. All right, now looking at our problem, what is our concentration of HC7H5O2? 0.1. This is in the liquid phase, so guess what? Concentration doesn't matter there. What is our initial concentration of hydronium? We haven't produced it yet, so it's 0. What is our initial concentration of our base? 0. All right, so now we're looking at the change. What's going to happen to the concentration of our acid? It's going to go down, so that's going to be minus X. What's going to happen to these concentrations? They're going to go up, plus X. All right. Now, right here, so we have 0.1 minus X, we have plus X, and we have plus X. So now, what we can do is, what other information did they give us in the problem? What can we determine from pH? Concentration of H. What is the concentration of H going to actually give us? Isn't concentration of hydronium the same thing as the concentration of H+? So that gives us X. So if we take 10 to the negative 2.59, that's going to give us the H3O concentration, which is X. So what is the concentration of H3O? Oh yeah, y'all are right. All right. So this is going to be 0.00257. I'm not going to worry about sig figs right now. So that means that X equals 0.00257. All I'm trying to do by showing all of this is give a grader more information to look at so that I don't lose any points. I want to try to show as much as I know in all of that. So that means that this is 0.1 minus 0.00257. This number is 0.00257. This number is 0.00257. All right. So I want to know the question is actually asking me to calculate the magnitude of the equilibrium constant. What do we label an equilibrium constant as? The constant for equilibrium. What letter or symbol do we use? K. And since this is for an acid, I'm going to call this Ka. All right, it's going to be whatever you choose. You can call it Kc if you want. K is what it is. I'm just saying Ka because it's an acid. And so my rate law or my reaction law would be products over reactant, right? So I'm going to have concentration of H3O. I don't know why I put the plus on the outside. It's going to be H3O plus times C7H5O negative over, I don't have to show water because water doesn't matter in this, my acid, concentration of my acid, HC7H5O2. And then now all I have to do is just plug in my numbers. So Ka is equal to, I'm going to take a shortcut, 0.00257 squared, because I'm just multiplying it, the same number by itself, over 0.1 minus 0.00257. So what does Ka equal? All right, so I'm just going to put it in 2 sig figs. So 6.8 times 10 to the negative 5. All right. Last one for today. Maybe not. We might be able to do all of them. All right. So let's do this one real quick. This one is calculate the magnitude of equilibrium. So we are looking for K, equilibrium constant for an aqueous solution of ammonia. What do we know about ammonia? Is it an acid or a base? It's a base. So we're going to calculate Kb this time instead of Ka. Now, first step, what do I need to do? Set up a rice table. All right. My reaction, what is the formula for ammonia? NH3. What am I going to add it to? Water, H2O. And it's going to have my equilibrium reaction, so I'm going to produce what? My NH3 is a proton acceptor, so what's going to happen to this? It's going to become NH4, and then I got rid of a hydrogen from water, so that becomes OH negative. All right. Water doesn't matter in the reaction, so my initial concentration of ammonia is 0.100. My initial concentration of ammonium, 0. My initial concentration of hydroxide, 0. What is the change? Is this going to go up or down? Down. Minus x, so that means this is plus x. Plus x. So I have 0.100 minus x and then I have X and X. Now, again, this one gave us this nice little thing, but can I use this as it is? What do I need to do? I need to get POH. How do I get that? All right, so POH equals 14 minus 11.3. So POH equals what? 2.7? I got 2.87. All right. So from POH, I can use 10 to the negative POH equals concentration of hydroxide so OH negative equals what? Which equals X. So this is 0.00135, 0.00135, and this is going to be 1.00 minus 0.00135. Set up my KB equation. KB is going to be equal to concentration of NH4 over times concentration of OH over that's not a plus. So setting it up, we have 0.00135 squared over 0.100 minus 0.00135. Solve for KB. All right, so we got 1.8 times 10 to the negative 5, and that is correct. I'm trying to find something for you real quick. All right, I'll have to look up what table it is, but if you look up the KB of NaOH in the table, you're always going to find that number. You'll get real used to seeing that number as 1.8 times 10 to the negative 5. After we're done with this unit, you'll know that one almost memorized. Now, we have time for one last problem. And this one's going to be set up, this one's going to be a little bit different, but we're still going to do the Rice table first. So again, it says calculate the pH of a solution which is which is 0.712 molar CH3NH2 methylamine. And then this time, instead of giving us a pH, they actually gave us the Kb. So one of the things we need to know, so the first thing we need to check is the classification of this particular one. This nitrogen should key us off that this is a nitrogenous base. So that's the other thing that tips us off that that's a base is the fact that they gave us a Kb instead of a Ka. All right, so I'm going to set this up, CH3 NH2 plus water, my equilibrium reaction. I just need to do my conjugate acid and conjugate base now. So if this is the base, how is it going to change? It's gain a proton. So I'm going to go CH3 NH3 plus, and then water is going to lose a proton, so it's going to be OH negative. All right. Initial concentration 0.712. Water doesn't matter. This one is 0, that one's 0. This is going to go down. This is going to go up. And this is going to go up. All right, so we have 0.712 minus X. X and X. Now, in this equation, I technically don't have enough information to solve for X without going through a quadratic. I don't want to take my time and set up a quadratic. So right at this point, I am going to drop my X. All right, and I'm going to show you a way to verify that it's okay to drop the X at the end. We're going to do something called the 5% rule. All right, so basically if percent dissociation is less than 5%, then you can drop the X. All right, I'm going to show you how to verify that at the end. So right now we're just going to assume that the dissociation is less than 5%. I can tell you when you have to do these on the AP exam, the majority of the time, they're always going to be less than 5% because they don't want you taking time doing that extra step. So we're going to go ahead and set this up. We're given a Kb, so our Kb reaction is concentration of CH3 NH3 plus. I'm going to show you in just a minute. Times OH negative. We're just going to assume that it's less than 5% at this point. Over CH3 NH2. And so now I can plug in my numbers. I have 4.4 times 10 to the negative 4 equals X squared over 0.712. And I'm just dropping the X from this part because it's going to mess me up in my overall equation. So I don't want to deal with it right now. So that means that x is equal to what? It's going to be a really small number. Hmm? So 0.712 times 4.4 times 10 to the negative 4. All right, so I've got 0. This is the number I had, 0.0176999. Let me try it. 4.4 second E negative. That's a negative 4 times 0.712 equals, so yeah. All right. So I'm just going to make this statement down here. X equals concentration of hydroxide. And so from there, I can take my 10. No, sorry. I can take my concentration of hydroxide and get POH, right? So POH equals negative log 0.0176999. So POH equals what? .75. That means my pH is 12.25. All right. Now, so how do I verify that it was okay to drop my X? I'm just going to come down here at the bottom. The only numbers that you need is this number and your original X, this number. Basically, we are going to do a percent error calculation. So I'm going to go my X over my original times 100. So when I set that up, I have 0.01769 divided by 0.712 times 100, and that's going to give me a percent. If that percentage is less than 5%, it was okay to leave the X off. So what do we come up with for a percentage? So about 2.5%. So it's okay to drop X. All right. For homework tonight, I want you to complete the 10B worksheet, and we will check it tomorrow.